In class example 3.32, we will convert equations to exponential form in order to determine the value of an unknown. Note, in part A, this conversion will not be necessary, but I'll discuss that after. Let's first write this in terms of exponential form. Our base of 5 on the logarithm becomes the base of the power. The output or answer to a logarithmic term is the exponent, so x becomes the exponent. And the argument of the logarithmic term, is the value of the power. So we see 5x equal to 1 over 125. Because we know that 125 is 5 cubed, 1 over 125 must be 5 to the negative 3. As we can see, by rewriting 1 over 125 as 5 to the negative 3, we can determine that the exponent of x must be equivalent to that negative 3. Therefore, our solution is x equals negative 3. It's worth noting, in part A, we didn't need to rewrite in exponential form. We could have simply interpreted the logarithmic term as asking the question, what exponent goes on 5 to make 1 over 125? Because the answer to that question is already negative 3, we could answer without converting. In part B, however, we're asked what exponent goes on 2 to make x, and are told the output, or the exponent, is 5. Here, it will be much more practical to convert to exponential form in order to answer our question. We rewrite log base 2 of x equals 5 as 2 to the power 5 equals x. At this point, we simply evaluate 2 to the 5 and find that x is equal to 32. Example C will bring up an important topic regarding domain and restrictions. But first, let's solve for the unknown value of b. Here we start with log base b of 81 equals 4, an equation written in logarithmic form. In this example, we see that we can rewrite the logarithmic form in exponential form as b to the power of 4 equals 81. We now raise each side to the power of 1/4. This effectively reduces the b to the 4 to b to the 1. On the right side, it becomes 81 to the 1/4, which represents the fourth root. Now, when solving equations, if we introduce an even root, such as squared or fourth root, then we must give both the positive and negative root. So technically, our answer here is b equals plus or minus 3. However, because b represents the base of a logarithm, and because neither the base nor the argument can be negative, we would then reject the value of b equal to negative 3, and would keep only b equals 3. So our solution is correct here. The answer is uniquely b equals 3. But in a written response, I would hope for students to recognize that the fourth root of 81 is positive or negative 3, and the negative 3 is rejected for reasons of domain restrictions. In some of our earlier examples, I said that when x was already isolated, there wasn't really a need to convert from logarithmic to exponential form. However, in part D, unless it's obvious to you that 64 to the power of 3 over 2 is equal to 512, it's probably easier to convert this to exponential form. Once in exponential form, we can rewrite 64 to the x and 512 both using a base of 2. We then eventually arrive at the result of 2 to the 6x equals 2 to the 9, and can conclude that the two exponents must be equal. From there, we simplify our fraction and find that x equals 3 halves, which we can confirm is the value of log base 64 of 512.